Xin lỗi các em một chút nhá. Bây giờ mình 2 phút nữa mình bắt đầu nhá. Bây giờ được 28 người rồi, 2 phút nữa mình bắt đầu. Hello? Hello? All right, so now we have 30% already in the class, and I think it's time to start. And yeah, initially I'd like to say sorry for the previous meeting because I was busy at that time. I have to I had to work with a new student coming into school, so that's why I had to cancel the class. And today we meet again. All right. Have you seen my? Have you seen the book, the syllabus, and also the first day presentation? Have you have a look at that? All right. Well, initially, I would like to share the syllabus, the content of the course. All right, here's the one. Excuse me, you guys, do you see it? Do you see the syllabus?
Có.
All right. So so here's the content. The general information. The first one is the syllabus for the EE 3230E, the electronic circuit one. All right. My name is Dr. Nguyễn Vũ Thắng, and my email is the thang.nguyenvu.com, and I prefer using the HUST email. All right. I'm working the lab called the IC Design Lab in the room 618 Tạo Quang Biểu Library. All right. The objective of the course. All right. You should be, after finishing the course, you should be able to explain, describe, use the physics-based design and circuit model for semiconductor device. You should be able to choose appropriate BGT and FET configuration. Also, you should be able to choose and calculate the appropriate biasing. Understand the effects of source, load resistance, power, frequency, feedback, analyze and design circuit. All right, that's the kind of stuff. Requirement: you should attend the class, prepare theory in advance. I will give you the lecture note in advance, and also point out what parts to do read, and then after that you should study in advance. Okay. And the team code of the class is you already have that already. Okay. And for this, all right, the homework would be like 50%. The project would be about 30%, and final exam would be about 55%. That's for the grading. All right. Any question on this? No. All right. If you have no more question, and I'd like to, for the class, the whole class, I would like to have, we have a monitor. And one vice monitor. So for example, in case we have something wrong, or for combination or do something, I would like to call the monitor. For example, I want to have the list of the people or the students to have the projects, and then the monitor should be the one who work on that. And for example, when we go back to the offline, and then if I have something, say I would like to want that guy, to go on that guy. All right. So I like to have a volunteer for the monitor. So yeah, who want to be the monitor, please?
I'm the monitor of
Đỗ Thị
this
Khánh Linh,
class.
right?
Yes.
Is that great? Đỗ Thị Khánh Linh. Right. May I have your phone number, please?
Yes. Can I text in the comment?
Sure, please. Can you just check it into the? All right. Oh, 904. I got that. Thank you. And also, your email should be link.dtk 182963 182963 at us.edu.vn, right? So your email should be like this, right? And here's your email, right?
Yes, that's my email.
Is that right, Link?
Yes, that's my email.
Okay. I need another person be like vice monitor, please. Do you have vice monitor or anyone can volunteer, please? No one. Okay, so if no one volunteer link, could you please could you suggest me give me one name, please? It should be a boy. All right. It should be a guy who's like do not miss session, do not and yeah, also reliable. Just two things: reliable and not frequently omit class. Can you give me one name, please?
Actually, our class have one vice monitor, so I can suggest him for you.
Yes, please.
I will mention him in the comment.
All right, please.
And my email seems like missing the edu in my email. It
Excuse me.
must be in my email.
Yes.
I think it's missed the edu.hus.
Can you retype it?
Yes.
And Hui, can you give me your phone number, please?
Yes, okay.
Sys.host. Okay. Thank you very much, kindly. I haven't seen your phone number yet, Hui. I just see that, well, my phone number is here, but I couldn't see it. Ah, here, the one. It's up here. All right. And here's the textbook. The textbook should be the Boyle Start and the other one, Boyle Start and Louis Nasinski. It's called the Electronic Device and Circuit Theory, the 11th edition, published in 1980. All right. I already have the book on the 5 of the team already. Do you have it?
Yes, we can see it.
All right. Okay, so the other one, and you can reference if you want the book. You another pretty good book is the Manvino one. It's called the Electronic Principle. And then after that, Richard Geiger, the microelectronic device is a kind of like concentrate a little bit more on the designs in the lower level. Like it's a kind of like, for example, our class concentrate on suppose that you are knowing that you already have devices, okay, and then when once you know that you have the devices, you can use it, to make circuits. So that's the one. But for the Jagger is a kind of like more concentration on the analog IC design. So it means that you have to understand a little bit in the operation of each devices. Uh, what is the parameter when depending on the structure of the transistor. For example, when you change, for example, if the width is bigger or the length is bigger, what will be happen? When, for example, if they use this technology, to make the transistors, what will happen? It's a kind of that. So that the second book on the microelectronic devices, it will be a little bit more on physical part. Okay. And the next one, the book called Kỹ thuật mạch điện tử 1 and 2 of Professor Phạm Minh Hà. In fact, it's pretty good in theory. And but for example, if you want book a kind of like easier to understand or easier, to use, to make circuit, you can search the book on, for example, of the flea market or something. I can just put the book on up there. It's in Vietnamese. Sorry, but for example, for the book that tell you how to do, what to do, and how to get the transistor from the flea market or something is better in Vietnamese. Okay, I will get it and upload over there in the file for you guys. Okay, later. All right. So that's talking about the books, and here's the content. All right. So for today, I have the introduction, and then after that, we talk about the diode application. Some mention about the BGT and FET because I believe that you already studied the BGT and FET, and a few of that on the previous course. Called the what is called the devices, right? Okay. And then after that, we have the talking about the BGT bias, small signal, and FET bias, small signal. And then after that, I will talk about the project introduction, requirements, the software, the flow, the testing, everything. And then I will want to get the project name and group decisions from you guys. And then after that, for every like next 5 weeks, we will follow the project schematic question, um, and why continuing on the compound configuration, the effect of the load and the source resistance, and the frequencies response, power amplifier, feedback, op-amp. Op-amp, op-amp we want to eliminate from this because like a little bit like it might be it might move to the electronic circuit too, but we already decided it for the normal for the standard program, but we haven't decided in the electronic circuit one in the advanced program yet. So let's see. And then after that, we have the circuit project presentation. You guys have to have the project, the circuit, and then you present it. You have to show the circuit and define your circuit. That's the kind of the content. All right. And I also have the homework right here for you guys. Okay. Now, question and answer about the syllabus, the content of the course, please.
I have a question.
Please.
In the project, we have a team of how many people?
In previous course, I have I have 2 or 3, but since last semester, I go for one. So everyone do their own project. So and I find that it pretty good because like it seems that you guys have to do it by yourself. Everyone have to understand it, have to make it by yourself, and because I can see that the class is not real big. We have like 36, 37 people, something like that, and so that's why I believe that we might have enough time, to go for that. If we have
So
2%, if not, maybe we have like a group of at most 2%. That at most. But I prefer to have 1% for one circuit. That I will decide it a little bit later, but that is come out top of my mind at the moment. Yeah, I do that because I just think well, for the electronic circuit, if you do not touch it, if you do not buy the transistor, if you do not like try to do it by yourself, you learn very little. So that's why I prefer that you make it by yourself. Any other question, please? Yeah, and believe me, if you do it, if you do it by yourself, you learn a lot, and you like it, right? Now, question, please. Hello, hello. Any more question, please? No more question. Yeah. By the way, do you hear me clearly, or do you hear noises around?
it's just a little bit noise, but I think it's okay. We can still hear
It's
you
a little
clearly.
bit, but can you hear me clearly?
Yes, still clearly.
Okay. All right. Thank you very much. And you guys, do you have any more question about the content of the course and everything? No. Okay. You have no more question, and then yeah, let's see. Let's start. All right. For lesson one, it will be the introduction on the diode application. Wow. Initially I talk a little bit about diode, and then after that we talk about the diode application, of which the one of most important application is a rectifier. Okay. Let's see. All right, so content initially we have the diode overview, and then I think that the most important one, the application of diodes, the rectifier, and then after that we have the clampers, inner diode, and then after that we have the voltage multiplication. Okay, here's one. Hello. Percentage. Sorry about that. That the grading must be changed. All right, we follow the syllabus. That's when I work on that. I have that like a long time ago. So that's why it's every time every semester I change I adjust the midterm and the homework a little bit based on the content of the course. So that's why I. But it's pretty tough, you know, to change that one. Now here's the books. Okay. First one. All right. This one's a diode overview. You can see that we have the here up front here is the diode symbol. You have like the positive and you have the negative part, and you can see that the current, if you allow the current going through it in only one way. Okay, it's two terminal device. All right, for example, if you put the positive signal, positive voltage on the positive here and negative right here, and then it will have a current going through. And the diode circuit at that time is considered to be short circuit. While if you have the negative part here and positive on the other side, and then it considered to be open circuit. Therefore, if you draw the draw the output, the input output versus input, you can see that you have, when you have the VDD smaller than 0, you have no current. So that's why the current is equal to 0. But when you have the VDD greater than 0, and then you have the current equal to infinity, as open right here. Of course, I will remember that this figure is for the ideal one, ideal diode, not a practical one. And now, second one. The character of the ideal diode, so you can see that the voltage across of the diode is equal to 0. The current is equal to infinity. The forward resistance, therefore, is equal to 0. And the diode acts like a short circuit. And when the voltage greater than 0, and then you can see that the voltage across all of the voltage will be across the diode. The current equal to 0. The reverse resistance equal to R equal to VR over IR. And the diode act like open, so it means that the resistance equal to infinity. And wow, that one is for the ideal one. And here's the actual diode characteristic. All right, you can see that. In fact, when it's forward bias, is not when the voltage is equal to 0 and the current going out immediately. It has two types. There are two types of diode. You use the silicon or you use the germany. All right. If you use silicon, the dropout voltage on the diode would be like about 0 from 0.5 to 0.7 volt. While you use this germanium, it would be like 0.2 to 0.3. Like silicon dropout voltage, the drop would be equal to 0.5, 0.7 volt. Remember, and for Germany, from 0.2 to 0.3 volt. And also it depends on the temperature. All right, so you can see that initially, if you increase the VDD, if you let's take the positive part. If you forward biases, and if you start with VDD approximately equal to 0, you can see that the current is approximate to 0. Can you see it? Excuse me, can you see the picture?
Yes.
Yes.
Okay. So from the beginning, if you start with the forward bias, meaning that the voltage is positive, and then if you go up, you can see that from 0 to about 0.3 or 0.4 volt, the current is approximately equal to 0. All right, and after that, when the VDD increase, you can see that the current will go up. All right, and the black line is the one that they draw based on equation, and the green line is the one that they draw it on the actual commercially available transistor. But in fact, sorry, not transistor, is the diode. But in fact, there are a lot of actual commercially available diode. So that's why that one is a kind of like stand for only one kind of diode, and the other one by going around that, but it's not a lot of difference. Okay. Now, when you reverse bias, the current you suppose you have no current, but in fact it has some current. Although the current is pretty small, depending on how big the transistor is, the diode is, and is that the silicon or germanium. It depends. Okay. And also it depends on the differential voltage that apply on the two sides of the diode. Okay, on the two terminals of the diode. So it will depend. Like for example, if you have the diode will be very small. So if that's the case, and then you have less electron coming from one side to the other, so it means that yeah, it's pretty tough in order to have very high current. But if you have the very big diode, it means that it can stand the forward bias very high current, and then of course when you turn it back, it will give you very high current too, comparing to other. Okay. All right. So here's a practical diode. You have like for silicon germanium. Comparing that, you will have like the silicon give you very high, a kind of like peak inverse voltage. So it means that it will allow you to have to apply the inverse voltage much higher than germanium. It also can the silicon can also allow very much higher current comparing to germanium. It gives you very much wider temperature range, because like when you have current going through the transistor diode, because the resistance of the diode, that a part of the power of the current going through that, it will become like it will become heat, and then it will make the diode hotter. And for the silicon, it allows you to get the temperature up to like 200 degrees Celsius. But in fact, they said that it can be up to 200 degrees. But normally, if you go close to 200 degrees, the operation of the diode will be much different comparing to the one that you have it working at like 30 degrees. So therefore, normally people do not allow the the diode temperature going up to close to 200 Celsius degree. It's the same story for, like, for example, for the chip. All right, yeah, comparing to germanium, it will be much higher, and also it have higher forward bias voltage. And the next one is a silicon diode, normally cheaper in Germany, in the one in Germany. So here's a question. So for example, in the practical diode, when you're comparing it, what kind of diode do you think that is better, the silicon or germanium?
I think it's silicon.
Hello? Which one do you think better? No one answer?
In my opinion, it might be silicon.
Excuse me?
I think it's silicon because
Silicon? Yeah, right. So if you say silicon, why do you think that silicon is better?
it will last longer with because it can withstand a higher voltage and with higher range of temperature, so it will stay long. It will have longer life than germanium.
All right. Yeah, you can see that if you list the stuff right here, you can see that well, most of the parameter of the silicon is better than germanium. It have higher PIV, higher current rating, wider temperature range. For the higher forward bias, it's like sometimes it's better, sometimes it's not that good. All right, so generally the silicon will be better than germanium. Yeah, but a few more thing is silicon is much more available. When you make it, it's cheaper. Okay. So if that's the case, if you find something are way better than the other, so it means that the other one should be eliminated, right? Because every other thing is better. So why the germanium is still there? Why they still use it? That's the question. Can you find out the answer, please? Uh, Link, it's raining. It's raining. I'm not sure that it's a. Is that? Do you still hear me clearly, or do you think that I should move?
Yes,
You
still
still can
clearly.
hear.
You still hear it clearly?
Yes, yes.
Okay, so that's pretty good. Thank you. All right, that's a question. So, can you find a kind of like a good thing about germanium diode, please? You have 2 minutes. Hello? Hello? Hello?
Yes, I can hear you.
I think that you already studied previous course, you know, came to electronic device, right?
Yes, we have just studied in the previous semester.
Yeah. Okay. So, do you know about the advantage of the germanium comparing to silicon?
I think germanium has a lower voltage drop, so it results
Yes.
in lower power loss, so it can be more efficiently in the working.
Yeah, I agree. Yes, but like um, but generally because you can see that all other disadvantages from the germanium, so that's why the majority of the diodes they use the silicon. Yes, and because although the dropout voltage 0.2 to 0.34 is significantly smaller than silicon, silicon still prefer using in most of the most of diode. So and normally there only one application that they use germanium because do you know the mobility? Do you know mobility? Đúng không?
Tính linh động.
I just type in the whole the electron mobility. Do you know it?
Là tính linh động của electron và bộ đen.
Excuse me, can you raise your voice, please? I couldn't hear you.
Mobility là tính linh động.
Okay, so what does it mean? Okay, so tính linh động. What does it mean? What does it affect? What's the effect of the mobility? Okay, germanium have higher hole and electron mobility. So what does it affect? What's the effect of the higher hole and electron mobility?
Can I answer?
It can function to a higher frequency.
Can you raise your voice, please? Because like it have a little bit like raining outside, so and it has some noise. So that's why you can raise your voice. It would be much better for me to understand.
Because it has higher hole and electron mobility, so it can function up to a higher frequency.
Okay, that's right. But like, do you know why you have the higher mobility, meaning that it can work in the higher frequency? Do you know why? Okay, so here's the one. All right, can you see the bigger picture that I just put in the conversation? Can you see it?
Yes.
Okay, so here's the thing. Like for example, suppose that you if you connect the whole thing together with a metal line, and then the electron will move in a metal line with the speed of nearly the speed of the light. So it means that it's extremely fast. Okay, that's the speed of the electron in metal line. So when it come into a diode, for example, it coming from the metal contact from the left, go to the metal contact to the right. The speed in the metal contact, in the metal, originally around like the light speed. So it means that extremely fast. But when it come in the semiconductor region, the speed will reduce significantly. About like 1 over maybe like more than 1 over 1 million. The speed that it will reduce like about more than 1 million times comparing to the speed of the electron in the metal all right, so it means that it takes times to come to go from one metal contact on one side to the other side. And it means that for the working speed of the whole circuit, the movement, the speed of the movement of the electron in the hole inside the semiconductor region in the diode is the one it will decide the operation speed. Understand? Do you understand what I said?
Yes.
Excuse me? All right, let's see. Do you have any foreigner inside the class? No, we do not have anyone. Okay. No. Just remember the in the for example, if you connect a transistor or a diode together, to the movement, well, the speed of the speed of the electron in the hole in the metal line, it will be millions times faster than the speed of the electron in the hole in the transistor or in the diode. Okay, so that's why the bottleneck is in the bottleneck of the speed. It will be in the diode, inside the diode. So that's why if we can increase the speed of the electron of the hole, or we can decrease the size of this, it will make the transistor of the hole, it will make the electron of the hole going past it shorter. So it means that we can make it in the higher frequency. All right. So because the size of the diode is limited, you just cannot reduce it as much as you want. No, you just cannot do it. So that's why you have to choose a material that give you very high mobility. So that's why in the operations that need very high speed of very high mobility, It means that they choose germanium. So that's why in fact, that's in the real world. You can find germanium's diode, but that one will be extremely small, and it always used for the high frequency. Because of that. Okay. Any question? Is that clear for you guys? Excuse me? Is that all right?
Yes, we get it.
Understand? Do you have
Yes.
question on this? Bọn em hiểu không nhỉ? Này có lẽ là
Thì nghe được không ạ?
Thầy có thể nói lại một lần tiếng Việt.
Có lẽ là như thế này. Bây giờ phải có một tại vì mình khi dạy này nhiều khi mình cũng không biết là bọn em nghe được hay không, bọn em hiểu được không. Nếu mà mình lúc nào mình cũng hỏi lớp trưởng thì expect bình thường là lớp trưởng là người học giỏi rồi, thì có khi lớp trưởng hỏi những hiểu nhưng mà người khác lại không hiểu lắm chẳng hạn, thì lớp trưởng có khi recommend cho mình một bạn là thuộc diện khá của lớp, tức là ví dụ như là em chia trình độ của lớp ra 5 phần thì một bạn nào đấy ở 2/5 từ trên xuống ấy, thì bạn đấy hiểu thì thế là ok. Thế thì và yêu cầu net của bạn ấy phải tốt, để có vấn đề gì mình hỏi ok chưa, bạn ấy bảo ok thì mình đi tiếp. Alo. Any suggestion? Or you think that you said that is that yourself doing that, Linh? Okay. So Hoàng Lâm Vũ, Linh said that it should be Hoàng Lâm Vũ. All right. Thank you, Linh. And Hoàng Lâm Vũ, do you understand what I said about what I'm talking about, the silicons and the germanium diode?
Can you give me one specific example of germanium application? Diode?
Okay. All right. For example, when you have let's say a radio receiver, right? In the radio receiver, it will have something like this: the antenna, right? And the antenna will give the antenna initially will have the antenna. Initially, the antenna will get the microelectronic. Sorry, not the microelectronic. The electric, the electromagnetic signal. All right, it will receive the electromagnetic signal, and then after that, the signal will be amplified. All right, in the amplifier. All right, so initially you have the antenna, to get the signal. That you know that where we live here, it's always have like thousands of electronic magnetic signal around you. Okay, you just want to, if you want to just get it, and then you have a device to get it, or if you do not want to get it, you just ignore it. And for example, your body normally cannot recognize that about this kind of signal. Right. So, for example, if you want to receive a signal, initially you have, and suppose that you have a radio receiver. Okay. I believe that well, in the past, a lot of family have it, but right now you do not see it a lot right now. Okay, so initially you have the antenna, and after the antenna you get the signal. The signal. So why you need after the antenna? Why do you need an amplifier over there?
Maybe because the received signal always so weak and a lot of noise.
Yes, exactly right. Well, it's always the signal always extremely small. So why the signal is small? Why you do not make it big? Why the electromagnetic signal is small? Why people do not make it bigger? Any answer? Yes, that's one thing. So efficiency. If you make it and then the power should be much higher. But another thing is, for example, if you have like the too much power, it will affect your body. It affects the life of everyone, every creature around that. So that's why the people have a kind of like the rule for the rule for what are they called, the power of the rule of the was the rule of the power of the electromagnetic field that do not harm people. People have a kind of like the rule about that. So, for example, if you have something to emit that, that one have to be below that power. So that's why another thing, you just cannot go higher than that, and that one is pretty small already. Okay, so there are two things. So the signal, because it's very small, so that's why it will be amplified. All right, after amplifying it, you have a kind of like normally you know that the signal that you get is a kind of like the carrier only, right? You got carrier. You understand that?
Yes.
Yeah. And then after that, you have to modulate it. Do you know that one? Yeah, exactly right. Uh, it's not totally that it's modulate. It means that điều chế in Vietnamese, and that's called the giải điều chế. And yep. And you also have the before that you might have, it depends, it have some have the mixer or it and you have a kind of like frequency frequency conversion. All right. So it's a kind of like initially you have like, so it depends on, you might have to do the modulate, you might have to do the frequency conversion. You have to convert the frequency down. Okay. So for example, for the demodulation, you need something that can work with the high frequency. And when you demodulate that is when you can use the germanium diode. Because the frequency, for example, if you have a kind of like AC, do you have AM? You know the AM signal, right? Or FM? When you have the AM and FM, if you get the signal, and then after that you have to demodulate the signal, and then that's exactly where the germanium diode is used. Okay, they put it there, and then it would be extremely small signal, extremely small diode, but you let the signal coming in, and it have only a part of signal coming out. Okay. So that's an example of how to use the germanium diode. That's where it is. Let's see if I can find it. Here's one. Yeah, I found it right here. Yeah, that's, and then I give you a kind of like a diode pictures. You can see that germanium diode is extremely small, and remember the outer part is make up the crystal, a kind of like glass, all right, and it's very big, but the germanium part inside is extremely small. It has a color a little bit black, the small dot right in the middle. You can see that. It's made of the germanium, and the outer part is a kind of like the glass over there, and then it will cover, to protect the germanium part only. Okay. Yeah, and that one is AM. I believe that one is FM. AM or FM right here. That Huang Lebu just send it out. Okay. And you can see that from the picture that I send it up right here. For the circuit, you can see from left to right, the diode, it marked blue over there. Can you see it? D1 is marked blue. Can you see in the circuits that I sent it up in the conversation?
Yes.
Is that all right for you guys? You see how to use it? Is that all right, Lam?
ảnh hơi bé thầy ạ, em đang xem.
Okay. Now let's go back. Okay. All right. That picture is comparing the germanium and silicon diode. You can see that the silicon diode it gives you a kind of like much higher dropout voltage. It's about 0.7 volt. And then germanium we have much lower, about 0.3 volt right here. And you can see that the inverse current for the silicon it will be much smaller. It's about like nanoampere. You can see that on microampere only. But for the germanium it will be like microampere, right? While this one a little bit higher than nanoampere, so normally it will be like 10 times different between silicon and germanium and silicon diode, and with the same size. Remember, the same size. Because like for example, if you have 0.7 volt dropout voltage right here for silicon, it means that it needs a pretty big barrier, you know, to have anything crossing that, you know, to go back. So it means that yeah, you have like 0.7 volt dropout voltage. It means that it's also being a barrier, you know, to protect it for the reverse current. So that's why if it's higher than germanium, the dropout voltage is higher. But the good thing is definitely have lower inverse current, because like instead of going past 0.3 volt, it now have to going past 0.7 volt. Okay, so something's good, are we going with the time something is bad every single time, right? So here example of the diode specific spec, right? We see the absolute maximum rating, temperatures, power dissipation, maximum voltage carrier, and after that you can see that the electric characteristic of max min units and test condition. All right. The next one, you can see that it's give you a few examples of the diode. All right. You can see that the germanium diode is extremely small, but you can see that on the example of B and C, you can see that you have huge diode right here. That diode normally can stand for very high current, so that's why you can see it's big. It's covered by metal, so it means that you can have it the heat dissipation very fast. So it means that you can stand very high power. Here are a few other examples. All right. So now, for today, I prefer that you guys study, read the stuff first before going to class. So that's why for today I just mentioned the things about the diode, the application and things. But for the more detail about the application, I think that we will mention it next time. Today we stop here. You go home, study, read all of the content, all right? And then after that, try to search something, and next time when we go back, we talk about it, and then please give me a question about that. Thế này nhá, có khi mình vì ở trong lớp toàn người Việt cho nên là có khi là để cho nó clear, để cho nó rõ ràng ấy, thì mình nói tiếng Việt của đoạn này. Tức là này, hôm nay ấy là mình dạy cái phần đầu tiên của diode, thì vì phần này là phần mà thực ra là các thầy cô đã dạy trước rồi. Mình nhấn mạnh vào là cái đối với diode cần phải chú ý cái gì và ví dụ của nó như thế nào. Thế còn sau đó thì tất cả phần thứ nhất là buổi sau sẽ xem tiếp về cái phần gọi là ứng dụng của diode cộng với lại có thể mention thêm với lại cả transistor. Thế thì mình prefer là khi mà vào lớp, trước khi vào lớp thì bọn em đã đọc trước những cái phần liên quan đến những cái phần liên quan đến nội dung học của buổi hôm đấy rồi, thì sau đó thì hoàn toàn có thể trao đổi với nhau nhiều hơn. Mình sẽ về phần dạy mình có thể nói ngắn hơn, xong rồi sau đó là chúng ta trao đổi, bọn em có thể có những câu hỏi mình, thì lúc đấy thì bọn em sẽ nắm tốt hơn và sẽ có hiệu quả hơn. Bản thân nếu bọn em không hỏi mình cũng sẽ hỏi bọn em. Ok, thì mình sẽ xem, mình sẽ đưa là cái syllabus một cách chi tiết hơn để bọn em, ví dụ trước mỗi một buổi bọn em cần phải đọc cái gì, chuẩn bị cái gì. Thế thì vì hôm nay bọn em cũng chưa chuẩn bị được nhiều, cho nên là hôm nay mình chỉ ngồi học đến bây giờ. Thế còn cái phần dạy thêm bù cho cái buổi này thì mình sẽ có vào những cái buổi sau, hoặc là mình sẽ làm một cái buổi hẳn một buổi riêng. Thế nào sẽ có những cái buổi mà mình chỉ dạy được 3 tiết chẳng hạn, thì sau đó mình sẽ dồn lại thành một cái buổi riêng để bù tất cả lại. Ok, chốt là như thế. Đối với bài ngày hôm nay bọn em có câu hỏi gì không? Có vấn đề gì về cái như mình nói về cái chuyện là cái cách học không? Có ai có hỏi gì? Có ai có trao đổi gì, có một cái đề xuất gì đấy để mọi thứ nó đối với bọn em cho nó tốt hơn không?
Thầy skip slide chậm lại một chút sao là tốt.
Hả?
Thầy chuyển slide chậm hơn một chút.
Ok, nếu mà như thế thì thực ra ấy là trong cái quá trình đấy tốt nhất bọn em viết luôn vào cái nốt ấy, thấy chạy chậm lại, thế thì lúc đấy thì mình sẽ biết. Còn nếu mà bọn em không nói gì, xong đến cuối buổi bọn em nói là thầy ơi chạy chậm lại, thì thực ra là nhiều khi là đến lúc đấy nó qua bén rồi, đúng không? Thế lần sau nếu mà bọn em cảm thấy là hơi nhanh một chút thì Lâm hoặc là nói chung là mọi người cứ báo lại một chút là thầy ơi chạy chậm lại một tí, thì mình sẽ chạy chậm lại nhá. Thì đến lúc đấy làm luôn thì hơn là đến cuối giờ nhá. Ok, được không?
Dạ được.
Ok rồi. Thế cảm ơn Lâm. Thế còn
Thầy ơi, vậy chỗ nào khó hiểu thì thầy nói tiếng Việt được không thầy? Nói thêm một lần tiếng Việt.
Cố gắng nói tiếng Anh thì nó sẽ tốt hơn. Thế còn nói tiếng Việt thì tất nhiên mình nói tiếng Việt thạo hơn nói tiếng Anh. Tất nhiên mình nói tiếng Việt được, nhưng mà nếu mà cố gắng, tại vì này thực ra ấy, cố gắng là những cái phần, những cái lý thuyết cơ bản ấy thì bọn em đọc sẵn ở nhà trước ấy, thì đến khi mà đến nghe nói thì bọn em đã hiểu trước một chút rồi, thì đến khi hoặc em hiểu trước rồi thì đến khi nghe nói nó dễ hơn. Thực ra ngày xưa mình đi học cũng thế mà, cái phần hồi đầu tiên, mấy tháng đầu tiên học nghe thầy giáo giảng bằng tiếng Anh mình có hiểu quá gì đâu. Thế cho nên là cuối cùng là sau một buổi đầu tiên thì rút kinh nghiệm bằng cách là đã có lịch đấy sẵn rồi thì về cứ đọc trước, hiểu trước rồi thì đến khi thầy nói thì mình chỉ cần hiểu lại thôi, thì đấy cũng là một cái cách học tiếng Anh mà.
Vâng, thế thầy up hết tài liệu lên luôn.
Thế thì tất cả những cái đấy thì sẽ cố gắng là mình sẽ đẩy những cái dữ liệu các thứ lên sớm cho bọn em hơn. Thế còn có cái là bọn em học, nói chung là bọn em nên học trước, xong rồi sau đó thì đến lớp ấy thì mình có thể trao đổi với nhau được nhiều thứ hơn.
Dạ vâng.
Ok.
Dạ vâng.
Ok, có thế nhá. Ok, ngoài ra có vấn đề gì khác không? Có câu hỏi gì không? Ok, thôi rồi, nếu bọn em không có hỏi gì khác thì chúng ta dừng ở đây nhé. Hôm nay thì mới học có 2 tiết thôi. Ok. Rồi, chào mọi người.
Em chào thầy ạ.
Rồi, em chào thầy ạ.